Unit 2, Review. Problem 1. The number of commercials X shown during a single hour of children's television programming is approximated by the following probability distribution. For a random sample of 24 one-hour blocks of children's television programming, find the narrowest interval that would accurately predict the mean number of commercials shown during a single hour of children's television programming 90% of the time. So this problem is asking us to find the narrowest interval. An interval is composed of two numbers that range from some lower number, L, to some upper number, U. So what we need to do is find the two numbers, L and U, such that the mean for this sample falls between them 90% of the time. Since the mean for a random sample is the focus of this problem, we know that the results of the central limit theorem can be applied, since this problem involves the mean for a random sample. One of the results of the central limit theorem tells us that the sample mean follows an approximate normal or bell-shaped distribution. So we can use our normal probability functions to solve this problem. Also, we're looking at the interval that accurately predicts this mean 90% of the time, means the interval, which ranges from the lower number L up to the upper number U, must capture the middle 90%, or 0.90, of the bell-shaped curve. And if the middle 90% of the bell-shaped curve falls within the interval, that means the remaining 100 minus 90%, or 10%, falls outside the interval. And due to the fact that the normal distribution is symmetrical, we can equally divide that 10% in half and put 5%, or 0.05, on the lower side, and the other half, 0.05, or 5%, on the upper side. Together, we have the lower 5%, the middle 90%, and the upper 5% make up the entire 100% of this normal bell-shaped curve. Now, since we know the probabilities associated with this normal distribution, and we want to find the numbers that make up the interval, L and U, we can use the TI-84 inverse norm command to find these numbers. To get to the inverse norm command on the calculator, we press second and vars to get to the distribution menu. Then we arrow down till we find the inverse norm command, press enter to select. The first number that's entered in the inverse norm command is the less than probability. That is, the probability of the normal distribution that is less than or to the left of the number we are trying to calculate. So when calculating the upper value of the interval, we need to enter in the area that is less than the upper number. The area less than the number U includes the middle 90% of the curve and the lower 5% of the curve. Together, there is 5% plus 90%, or 95%, less than the number U. When we enter the value in the calculator, being it's a decimal machine, we need to enter in 95% in the decimal form, 0.95. Now, when doing the inverse norm command to find L, the lower value, again, we enter in the less than probability for that number we seek, and the less than portion of the normal distribution that's below the L, the lower number, is 5%, or 0.05 decimal. After we enter in the less than probability in the inverse norm command, we press comma, and then the second number we enter is the mean. When looking at this problem, we find that the mean is not given in the problem. Instead, we will use the probability distribution in our calculator to calculate the mean and standard deviation for us. To do this, we enter the probability distribution into lists in our calculator by pressing Stat and Enter to enter the list editor. Make sure to clear out lists of any old data to make room for the new information. We could then enter the X values into the first list. and then enter the probabilities of those x values into a second list. And then on the calculator, we could execute the OneVarsStats list1, list2 exam. We do this by pressing Stat, right arrow to the Calc menu, and press Enter. That brings up the OneVarsStats command. Then we tell the calculators the lists we entered in the data. Press second 1 to bring up list 1, comma, and then second 2 to bring up list 2. When you press Enter, the screen reveals the calculated statistics. So the calculator shows that the sample mean x bar equals 15.11. But we know what this really is the population mean mu equals 15.11, because this probability distribution accounts for 100% of everything that can happen. So in the second number after comma in the inverse norm command, we would then have to enter in the mean of 15.11. Then you press comma, and the third number is the standard deviation. Again, looking at our calculator screen, we see that the population standard deviation sigma is equal to 1.17. But after we enter in this population standard deviation of 1.17, we recall that the central limit theorem tells us that the standard deviation of the sample means is equal to the standard deviation for the population divided by the square root of n, the sample size. So after entering in the standard deviation of 1.17, we then press divide by, second x squared to bring up the square root, and then 24, because this is for a random sample of 24 one-hour blocks of children's television programming. We then close the parenthesis, press enter, and the calculator will find the values for us. When we use the inverse norm command with the 0.05 less than probability, we've calculated the lower end of our interval, which rounds off to 14.7. And when we use the inverse norm command a second time, using the 0.95 less than probability, we calculate the upper value of our interval, which rounds off to 15.5. Now, even though the number of commercials, x, is discrete, a whole number, this problem is actually looking at the mean for a random sample of 24 of these numbers. And the mean for a sample is continuous and can take on extra decimal places. So we need to round off carrying at least that one extra decimal place to help minimize our round off error. So now that we've found the two numbers that make up our interval, we can give our answer to this problem. For a random sample of 24 one-hour blocks of children's television programming, the narrowest interval that would accurately predict the mean number of commercials shown during a single hour of children's television programming 90% of the time ranges from a low of 14.7 to a high of 15.5 commercials per hour.